The overall goal of the following experiment is to determine the ability of fish to perform energetically demanding swimming behaviors. This is achieved by placing fish in a swim tunnel respirometer and challenging them to increases in water flow speed. During this time, oxygen uptake should be recorded, allowing for the determination of changes in metabolic rate due to exercise. Video analysis software can be used to obtain information related to swimming behavior. Results are obtained that show differences in swimming performance based on the top speed in which the fish could swim and the time it could maintain this speed.
This method can help answer key questions in physiological ecology concerning the energetic demands of swimming and its controlling mechanisms. Demonstrating the procedure along with me will be an honors student, Ms. Geneve Binder, from my laboratory.
Using a knotless net, collect individual fish from their holding tank. Minimize capture time, avoid collecting multiple fish, and do not hold fish for more than a few seconds in the net, as these factors can increase stress, and stress can affect swimming performance. Place fish in a freshwater transfer tank containing tricaine methane sulfonate anesthesia buffered with sodium bicarbonate. Anesthetized fish are then sexed, measured for mass and length, and given a cursory external exam of their condition. Measure the total length, fork length, or body length. Introduce fish into the swim tunnel as quickly as possible to aid in recovery. Set the flow rate such that fish will be able to rest on the bottom while barely swimming. An example rate for adult sockeye salmon is 0.3 bl per second. Place an oxygen probe into the respirometer. Monitor the oxygen levels in the swim tunnel during testing. Acclimation periods vary between fish. Here, a juvenile rainbow trout is acclimated for 30 minutes. To replenish oxygen, mitigate waste accumulation, and maintain water temperature, flush the tunnel periodically.
The most common way to characterize fish swimming performance in a swim tunnel is by the duration for which it can be maintained. The slower the speed, the longer the fish can swim, and vice versa. Speeds are generally referred to as burst, prolonged, or sustained, which correspond to durations of seconds, minutes to hours and beyond. To determine these speeds, fish are subjected to user-defined steps consisting of set height, i.e. water flow speed increases, and length, i.e. step duration. Maximizing step height and minimizing step length will capture the greatest burst speed, while doing the reverse will capture the greatest sustained speed.
Next, set up a video analysis system to record swimming behavior during the study. Video analysis can also be completed after the trials using recorded video. Following acclimation, increase flow speed according to step size and record the duration of swimming. If needed, a small charge delivered by a shock grid at the back of the swim tunnel can be used to encourage swimming. Once the fish stops swimming, end the test and allow a recovery period of 30 minutes. To capture burst swimming or sprint ability, bring the flow speed to an estimated maximum. Fish should be resting at the rear of the chamber as the flow speed is rapidly increased. Once fatigued, fish should be allowed to recover or removed immediately for tissue sampling. Determine the routine and maximum metabolic rates, abbreviated RMR and MMR, by calculating the volume or mass of oxygen per unit mass per unit time. In this example, RMR was 198 and the MMR was 961 milligrams of oxygen per kilogram per hour.
In the step test, the traditional way to report the maximum speed achieved is to calculate the speed of the last fully completed step plus the temporal fraction of the last final unfinished step.
The equation seen here is used to estimate prolonged or sustained swimming ability, also referred to as critical swimming performance, or U-crit. The cross indicates the point where the fish refused to swim further and where U-crit was calculated. Video analysis software can be used to determine swimming behaviors, such as the number of bursts and their length. The tail beat frequency and tail beat amplitude can also be calculated as seen here.
Following testing, samples can be collected to determine hematocrit levels, stress hormone concentrations, muscle energy stores, enzyme activities, or other physiological parameters.